Okay. Do you remember what this word meant?
Perpendicular.
Perpendicular. Sometimes when you highlight crooked like this, not that time, it thinks you're trying to draw a straight line. And since I started here and ended here, it just drew a straight line for me. That is the background computer wondering what's happening. Okay, so here we go. We want to find out if they're orthogonal. What do we know about this? Wow, that's still yellow. If it's orthogonal, the dot product between these two equals 0. Because here's my dot product. The formula says length of u, length of v, cos theta. The only way it can be equal 0 is if theta is 90, because cos of 90 is 0. So if the dot product is 0, we'll be able to say, yes, for sure, they're orthogonal, or they're perpendicular. Well, the vectors I have right now are 2m, m, and 8, dot product with 1, 3m, and negative 1, and that has to equal 0. Well, a dot product would say that I have 2m plus 3m squared minus 8 equals 0. How do you solve something like that? Factoring. So I'll write it. This one's not too bad to factor. The only way you get 3m squared is 3m and m. How about 2 here and 4 there? Make the 2 positive because the outside would be 6. Minus 4 is 2. So m is equal to 4/3.
You got your signs messed up.
Yeah, because the middle number has to be positive, and then 2 minus 4 is negative 2. So that would be 3m squared minus 2m.
But if I do the outside, I get 6m. All right.
Thanks,
It's hard to get that 100% in this test.
It's too late for that.
So, have we solved the whole question? Just said, find the value or values. Oh, I gave a hint that there might be more than one. Ooh. I should do that on every single thing. Would be find the values of m or m's for which the vector or vectors this are orthogonal. There we go. Then it would be good. All right. So we got a vector u. Give a vector that's parallel to u. Give one that's not parallel to u, and give one that's orthogonal to u. Which of those three do you think are easiest right now? C, because we just did orthogonal. Okay, let's start with C. We've got 4 and negative 3. You need to figure out something here so that it equals 0. Any suggestions? 2 and 2? Nope. Because 2 and 2 would give me 8 minus 6 doesn't equal 0. It's close. 2 And 1.5 also will not work. 0 and 0, it will not work because 0, 0 is not actually a vector. It's just like a point. It doesn't go anywhere. But you're right. If I have 0 and 0, I will get 0.
3 and 4.
3 and 4? 3 and 4. Check it out. You'll get 12 minus 12. Now, this is in 2 dimensions. When you did two-dimensional things prior with analytic geometry, you had slopes. Say the slope of one line was negative 3 over 4. Rise over run. And we did perpendicular lines. What did you learn about slopes of perpendicular lines? And you didn't take math and French. What did you learn about slopes of perpendicular lines? Flip it and change the sign. That's a nice colloquial way of saying it. See, the problem is in French, they use the word for flip it, they use the word inverse. And in English, we use the word reciprocal. He said flip it. All right, well, you go back and tell Mr. LaFrance to flip it. It is recording. What, are you making notes of what things you need to look up later on my YouTube channel? Okay, so we used to do negative reciprocals. Well, a vector as a direction vector is sort of the same thing. Instead of rise over run, it's x is on top, is run over rise. Can you see that all we did was flip it and overall made the fraction positive or negative in the same way as before? So you can use that as a previous strategy to help you figure it out. Not so easy with three-dimensional ones, but with two-dimensional, not bad. Okay, so we found one that's orthogonal. That leaves us with either parallel or not parallel.
Did you just put any two numbers for not parallel?
Possibly, but what happens if you'd picked something that was parallel in your two numbers? How would you check? Well, how did you know if here I've got negative 3 and 4, because that's my vector u is 4 and negative 3. If my slope was negative 3 over 4, and it was parallel, what do you know about the slopes? Has to be the same. So if you pick anything for your parallel vector, any multiple, let's say I double it, can you see that that could reduce to the same one? It's just twice as long. But twice as long would still be parallel. Or you could triple it, or quadruple it. So anything that way would be anything that, if you put it as a fraction, reduced to 4 over 3, then you would be fine. And not parallel, you just have to make sure that that fraction doesn't reduce. Change only one of them. Perfect. For sure that won't be parallel. All right, last question, and then we'll be able to go over our matrices test and take some time to work on the homework. So we have our one vector, which is 2 and x, and our other vector, which is 1 and minus 3. So we're going to use the idea that we did in the last example for parallel. If the one vector is 1 and minus 3, and the other vector is 2 and x, and if they're parallel, they'd have to be able to reduce. You would have to say, well, how could I get back to a 1? Divide by 2. So I'd have to do the same thing to get back to a negative 3. So what's x going to equal to? negative 6. Now, if they're perpendicular, what do we know? It'd have to be the negative reciprocal. So we know the answer is going to be positive. Okay, good. Yeah.
Then we also know the answer, the fraction have to be the same, but
Right.
so then you just be 6.
The fraction then wouldn't be flipped.
Oh, yeah.
2 divided 3.
So you could go 2 divided by 3 and do 1.5 there? Is that what you're saying?
The answer is 2 minus 3x equals 0, right?
2 minus 3x is equal to 0, yes. So what are you're using, what are you using? The dot product, right? So instead of thinking negative reciprocals, it'll be easier if you think the dot product. Now the dot product would be 2 plus a minus 3x equals 0.
2 divided 3.
So you'll get x is 2/3. Okay, I'll hand out your homework here.